Ladies and gentlemen, the next regression diagnostics that we want to look at is linearity. You remember one of the assumptions of the classical linear regression model, the Gauss-Markov assumptions, is that there is a linear link between the dependent and the independent variable. It is linear in parameters. It can be nonlinear in the independent variables. So some of the independent variables can have squares. They can have cubes. They can have square roots and things. No problem. But the parameters, the beta parameters have to be linear. How do you prove that this regression is linear? The component residual plots are a good way to check if these predictors, these regressors, these covariates, whether these independent variables have a linear connection with a dependent variable. So we use this command known as CR plot to do that. This command, which is called CR plot. So let's go to the R and then check the CR plot. So I'm just going to go to my and then check the CR plot. Okay, I'll just use that command CR plus into brackets gen multi. And on my right, you see those beautiful command there. Beautiful. Now it shows that particular independent variable and how it is related to the dependent variable and the residuals. So it's the components plus the residuals there. Now, what the CR plus is doing is that it's modeling the residuals of every one independent variable against the dependent variable. And what you do is that it's very good for testing non-linearity. Because what it does is that you can see it adds a line telling you where the line of the best fit lies. So when you look at this here, there is a line of the best fit, and then it adds a kind of another line, which is a kind of a purple line around the line of the best fit. And it helps you to know which particular independent variable might not be showing a linear link and therefore will need to be, considered as a nonlinear relationship. Of course, the dummy variables will not have a line, okay, because dummy variables are dummies, they are static. So it uses a box plot to indicate their connections. So those ones are not a big problem, okay. But you can see that there appears to be some kind of linear link between the the component residual, the Q, the dependent variable, and the price, and the complement price, and that of the others. There appears to be a kind of a negative sort-like relationship. But if you look at the complement price, it rises somewhere. So it kind of appears to, fall and then rises and then falls again, something like that. And the same thing with the income. Okay. So then the question becomes, what is our conclusion? Well, a significant difference between the residual line and the component line will tell you that there's a linear relationship. That is if there's a significant difference. If there's no significant difference, you can't conclude that there is that sort of linear relationship. Okay, so you need to check. And it appears to me that there appears to be a linear link between each dependent variable as well as the independent variable. If you are not that sure, sometimes you can just check it by, and we shall do this, okay? When we come to heteroscedasticity, we shall check all of this, okay? Okay, so for me, it appears that there's some kind of linear link, okay? Let's move on now and look at the next thing that we can do, still on linearity. Okay. One thing we can do is that we can invoke the library car command. We can invoke the library car command and then do residual plot analysis again to check for linearity. And to do that, the residual should be plotted against the fitted. This is the linearity of the residuals. Okay. And that is one way we can check for linearity. Again, these two that I'm doing, they are all not that seriously important. So please just note that this is just for you to confirm some few things. So let's go and check the results. And if we see the the residuals against each of the independent variable, it shows some quadratic relationship with some of the independent variables. Usually that, for example, with M and then C, there appears to be a reasonable quadratic relationship in there. But then price seems to be showing a linear relationship in there. So again, those two variables are variables that we will need to what? Check. Now you will later learn that one way to check it is take the log of the C and take the log of the M. Okay, and we'll do that later on when we come to looking at the particular situations. However, the test will tell you, okay, if there is a test, the test will tell you whether they are problematic or not. The key point is that if any of these plots should show some systematic shapes, okay, then the linear model is not appropriate and some nonlinear terms may be needed, as we have seen the quadratic situation with the variable M and C. So that is it. That is how you can check for that. Okay, so that is how you can analyze linearity. When we come to heteroscedasticity, we'll look at that even more.